Day 251 of doing a LeetCode problem every day until I get a job. All right, y'all, welcome back where we're doing daily LeetCode problems, and today we're at day 251, still going strong. Today we have question number 433, minimum genetic mutation. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy for everyone to understand. So let's get into it. Question says, a gene string can be represented by an 8-character long string with choices from A, C, G, and T. Suppose we need to investigate a mutation from a gene string start gene to a gene string end gene, where one mutation is defined as one single character change in the gene string. For example, AACCGGTT turns into AACCGGTA is one mutation. There is also a gene bank that records all the valid gene mutations. A gene must be in bank to make it a valid gene string. Given two gene strings, start gene and end gene, and the gene bank, return the minimum number of mutations needed to mutate from start gene to end gene. If there is no such a mutation, return -1. Note that the starting point is assumed to be valid, so it might not be included in the bank. So let's break that question down and see what they mean by looking at example 1. In example 1, we have the input start gene equals a string AACCGG and TT. The end gene equals a string as well, AACCGGTA, and the bank is an array of strings with only one string being AACCGG and TA. The output is 1. So as you can tell, or as you can see, that the mutation happens right here. So this T right here turns into this A, and that's the one mutation that we counted for our output, right? And this end gene, which is the mutated gene, is included in the bank input, which means it's a valid gene mutation, which means it counts, and which means the output is 1, right? So as you can see, all of these letters are the same until we get to this T and end gene, and it's the same thing and with start gene, and it's the same thing in end gene, except for this A. We mutated this T to an A. It's valid because that mutation occurs in the bank array, so the output is 1 because there was only one mutation, which was this A from this T. So let's look at example 2, where there's a little bit more mutations and the bank is a little bit longer, so we can see exactly what it is that they want us to do in case they try to throw some trick questions our way or something. So in example 2, we have the input start gene equals a string AACCGG and TT. The end gene equals AAACGGTA. Bank equals an array of strings. We have the first string is AACCGG and TA. Second string is AACCGCTA. And the third string is AAACGGTA. The output is 2. So as we can tell from looking at the start gene right here and this end gene, we mutated 2 letters, right? We turned this C right here. We took this C right here and we turned it into an A, and now we have 3 A's. Boom, we turned it into this A, and that gave us 3 A's. And we took this T right here and turned it into an A right here. So now that's the second mutation. So once again, this C we turned into A. That's one mutation. And this T we turned into A. That's another mutation. And this final end gene right here is included in the bank array right here. So we have AACGGTA and the end gene, and right here the third string in the bank array is AAACGGTA, which makes it a valid mutation, and we mutated 2 of these letters, this C and this T, so the output would be 2. So now that we understand the question, y'all, let's get into the fun part, the actual code But before we get into the code, y'all, don't forget, if you need any new Apple AirPods, go ahead and check that link out in the description. And then after you do that, go ahead and like, comment, and subscribe, y'all. Now, remember, when we're writing the code, we are just counting the mutations. We don't need to mutate anything ourselves. We just need to count what's been mutated. And in order to do that, we're going to use a breadth first search. So let's get into it. Let's figure out how we're going to do it, right? So the first thing we are going to do is we need to check if the end gene is in the bank or not. If it's not in the bank, that means it's impossible to reach, and then we could just return -1, right? So it says right here, if there is no such mutation, return -1. So if the end gene is not in the bank, we can return -1. So in order to do that, we're just going to use a guard statement. We're going to say guard bank dot contains, open up the parentheses, end gene, come outside those parentheses, and we're going to say else, open up the brackets, return -1. Once again, this end gene comes from right here, so we just pass that into our guard statement. Now we need to find a way to convert the start gene and the end gene and the banks into strings or into an array of characters, so it will make it easier for us to mutate as we go through our solution, right? So the first thing, in order to do that, we're going to say let ch start equal an array, start gene. Boom. So we're going to turn start gene into an array of characters. And then we're going to say comma. We're going to do the same thing for the end gene. So we're going to say ch end equals an array of end gene, right? Because remember, they're starting off as strings. We're going to convert them into an array of characters so we could manipulate them a little easier, right? Now we need to convert the bank into an array of strings, right? Well, we need to convert each gene in the bank to a character array, right? Because a bank is a bank is an array of strings, so we need to handle that as well, right? So in order to do that, whereas this is just a string, bank is an array of strings, so we need to handle it for that case where it's an array. So in order to where it's an array of strings, so in order to do that, we are just going to say let ch bank equal bank dot map, open up the parentheses, open up the square brackets, array, boom, open up the parentheses, $0. Now what that is going to do is that is going to convert each string in this array into an array of characters, right? Whereas this, we just converted this into an array of characters. We need to convert each string in the array into an array of characters. So that's what this is doing right here. This $0 represents each string in this array. So we're going to turn each string in this array into an array of characters. Boom. Now we're going to come down here. Now we need to keep track of the visited gene for the BFS, for the breadth first search queue, and we're going to start with the initial gene, right? So in order to do that, we need to create a list of genes that have already been visited. So in order to do that, we're going to declare a variable. We'll just call that visited, and we'll set that to an array of ch start. Boom, just like that. Now we need to create our breadth first search queue, and that's going to start with the start gene, right? So in order to do that, we're just going to say var, and BFS stands for breadth first search, right? Just so y'all know. So we're going to say var q equals square brackets ch start, just like we did before with the visit. Now we need a way to track the number of mutations. So in order to do that, we're going to create another variable. We'll just call that depth, and we're going to set that equal to 0. Once again, depth is going to track the number of mutations for us. Now it's time to actually perform our breadth first search to find the minimum number of mutations to reach the end gene. Excuse me, y'all. So in order to do that, we're going to start with our while loop. We're going to say while exclamation point q dot is empty. So while, what that means is the exclamation point means while q is not empty. So while exclamation point q is empty, what we're going to do, we're going to increment depth. So we're going to say depth plus equals 1. Boom. Now we need a list to store the next level of genes that we're going to process. So we're going to declare a variable by saying var next. We call it LVL for level, colon. It's going to be a 2D array of characters. Boom, just like that. Then we are going to initialize it with a blank array, just like that. Boom. Now it's time to process each gene in the current queue that we're working with. So we're going to say for q in q, for letter q in word q. We're going to open up the brackets, and now we're going to iterate through each gene in the bank. So for that, we're going to say for b in ch bank, where exclamation point visited dot contains, open up the parentheses, b, come outside of that, open up the brackets. So what this is going to do is we're going to skip the already visited genes. That's what this exclamation point is here for. And we are going to say declare a variable. We call it CNT for count. We'll set that equal to 0. And that's going to keep count of the number of different characters between the current gene and the bank gene. So now we need to compare the characters between the current gene and the bank gene. So in order to do that, we're just going to say for I in 0 up to 8, because remember, it's an 8-character long string. So for I in 0 up to 8, where b square bracket I, come outside the square bracket, exclamation point equal, so does not equal q square bracket I. We're going to come out, we're going to increment count plus equals 1, or CNT plus equals 1. So we're going to open up the brackets, say CNT plus equals 1. Boom, just like that. If there's more than one mutation, if more than one mutation is required, then we could just skip the gene, right? So we're going to do it. We're going to come down here, we're going to start a guard statement, and we're going to say guard CNT equals 1, else we could just continue just like that. Boom. Now we need to see if the gene matches the end gene and return the current depth or the number. Remember, the depth is the number of mutations. So we need to see if the gene matches the end gene and return the number of mutations, which is depth. So in order to do that, we're just going to say guard b does not equal ch end, else, open up the brackets, we could just return depth, just like that. Now we need to mark the gene as visited and added it. We need to mark the gene as visited and add it to the next level of our BFS, or our breadth first search. So in order to do that, excuse me, y'all, all we have to do is say visited dot append b, excuse me, open up the parentheses, b, just like that. And we need to come down here, and now we need to add it to the next level of our breadth first search. So we need to say next LVL dot append b as well. Now we need to move to the next level of our breadth first search. So in order to do that, we're just going to say, we're going to set the the q equal to next level by coming outside this for loop, and we're going to say q equals next level, just like that. Now, if we exhausted all of the other possibilities and we cannot reach the end gene, we need to return -1. So in order to do that, we're just going to come down here and we are going to say, come outside the while loop, and we're just going to say return -1. Boom, just like that. Now that should be all she wrote, y'all. Let's run it. Make sure it runs like it's supposed to run. Let's see. Okay, so we got a typo. Cannot find visited in scope. Oh, so I need to change visit to visited. My bad, y'all. So this should be visited, not visit. So let's run it again. See what happens. Let's see. And it's accepted, y'all. Let's submit it. Make sure it stays accepted after we submit it, because we all know how this LeetCode stuff can get. Let's see. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. That's what I'm talking about. Those are some good numbers right there, y'all. So I hope y'all learned something today. Remember, we're doing LeetCode problems daily, so make sure y'all check back in tomorrow. Come holler at me so we can do another LeetCode problem. Now, before we leave, get one more look at the code. Read it, learn it, love it, y'all. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.